Hi, what we are going to do is go through the solutions to many of the questions in tutorial 5. The questions are with you, so you can read the questions and then follow the solutions. You will need to pause the video and use a calculator and check the calculations as we go through the solutions, and that will enable you to enhance the learning process. One thing that I want to warn you about, it's raining outside my house here, and you might hear thunder in my videos, and when there's thunder my dog also begins to bark, so please bear with me. Okay, it won't bother our discussion. Question number 1, we are told that s equals to x1 plus x2 right up to xn, and we are told that the x's each have an exponential distribution with mean theta. The random variables are mutually independent, and we are told that n has a Poisson distribution with mean 1. Yeah, so let's write it here. N is Poisson, okay, mean 1. Let me hold the question in my hand. You are given the moment generating function. You're given the moment generating function of your aggregate distribution evaluated at 1. The value is given as 3, and you're asked to find theta. Okay, read the question carefully, see what they've given us, and we're asked to find theta. Now from the tables, let's look at the solution. Yeah, from the tables we can get the probability generating function for the Poisson distribution, so that will be e to the power of lambda times t minus 1. Now we need that because for the compound Poisson, the moment generating function for S, the aggregate distribution, will be, you plug in the moment generating function of x into your probability generating function. Again, you plug the moment generating function of x into your probability generating function of n. So we have the probability generating function of n, so just plug in mxt inside here. But we are evaluating the MGF at t equals to 1, so if you look up your tables, you will find that the moment generating function for your exponential with mean theta is given as this. And because we are evaluating at t equals to 1, this becomes 1 over 1 minus theta. Okay, this equals to mx1. So we are given ms of 1 is 3, so let's write on the left hand side is 3, so this is, let me write it here, 3 equals to e to the power of lambda, mxt will be 1 over 1 minus theta and minus 1. Okay, good. Lambda is what? Lambda they gave me equals to 1, so I end up with this. Okay, they gave me that n is Poisson with mean 1, so lambda is 1, and once you have this, this is a simple equation we can solve. Okay, we have e to the power of 1 over 1 minus theta times 1 over e equals to 3. Now bring the e up, you will get this line here, and then you can take logs, use a calculator and solve for theta. Not hard. Let's move on. Question number 2. A company has machine. Okay, a company has a machine that occasionally breaks down. An insurer offers a warranty for this machine. The number of breakdowns and their costs are independent. The number of breakdowns each year is given by the following distribution. So, number of breakdowns, this is the distribution. And the cost of each breakdown, we also have a distribution. To reduce cost, the insurer imposes per claim, a per claim deductible of 1,000. So, let me write the information given in the question. We have 1,000, 2,000, 3,000 and 5,000. Yeah, these are the values of the cost. Now, to reduce cost, the insurer imposes a per claim deductible of 1,000. Compute the standard deviation of the insurer's losses for this year. So because we have a deductible of 1,000, the insurer is responsible for this one, he will be responsible for 0. For this one, he'll be responsible for 1,000. This one, 2,000. And this one, 4,000. Okay? Because of the deductible of 1,000, after the deductible, these are the values X can take: 0, 1,000, 2,000, and 4,000 with the corresponding probabilities: 0.5, 0.1, 0.1, and 0.3. We're looking for the standard deviation of the insurer's losses for this year. So we're going to use this formula here that you see. The variance of S will be the expected value of N times the variance of X plus the variance of N times the expected value of X whole thing squared. So let's find out the expected value of N. Take 0 times 0.5, 1 times 0.2, 2 times 0.2, and 3 times 0.1. You will get 0.9. The second moments, expected value of N squared, 1 squared times 0.2, 2 squared times 0.2, 3 squared times 0.1, you will get 1.9. So the variance of N will be the expected value of N squared. Okay, let me write it here. The expected value of N squared minus the expected value of N whole thing squared. Use a calculator, you will get 1.09. Now, do the same thing for the expected value of X. 1,000 times 0.1, 2,000 times 0.1, and 4,000 times 0.3. The expected value of X is 1,500. Expected value of X squared, same idea, except we are doing second moments. And then using the same formula, expected value of X squared minus expected value of X whole thing squared, you can get the variance of X. Plug into this formula, expected value of N, 0.9, variance of X, I just worked it out. Use a calculator, yeah? And then the variance of N is 1.09, the expected value of X whole thing squared is 1500 whole thing squared. Clean this up, take the square root, and you get your answers. Next question. Let me read the question. For aggregate claims, S equals to x1 plus x2 right up to xn, you're given the conditional distribution of n, given lambda is Poisson with parameter lambda. Okay, I've written that here. Is conditional distribution of n, given lambda is Poisson with parameter lambda. Lambda has a gamma distribution with alpha 3. Okay, alpha equals 3 and theta equals to 1/4 as the parameters. x1, x2, x3 are identically distributed. They gave me, okay, x1, let me write that again, fx1 equals to 0.5, fx3 is 0.5. These are the numbers given in the question. Okay, good. They gave me that n, x1, x2, they're all mutually independent. Determine the variance of S. Okay, great. So, a few things. This is the information given in the question, and we know, we have studied this in our class before, given the conditional distribution of n and the distribution of lambda, we know the unconditional, I repeat, we know the unconditional distribution of n is good, negative binomial. R will be alpha and beta will be theta. So which means that your R here will be 3 and your beta will be 1/4. Good. Okay, the unconditional distribution of n is negative binomial. So from our formula sheet, we know the expected value of n now. Again, right, let me say that, it's important. The unconditional distribution of n is negative binomial. From the formula sheet, we can get the expected value of n, R beta. R beta will be 3 times 1/4. You'll get 3/4. The variance of n is R beta 1 plus beta. 3 times 1/4 times 5/4. You will get 15/16. The expected value of x is 2. How do you get that? Take 1 times half plus 3 times a half, yeah, from here. So you'll have half plus 3/2. forward to 2. Then you need to get the expected value of x squared, which will be 1 times half plus 9 times a half, which will be a half plus 9 over 2, which will be 5. So the variance of x will be what? 5 minus 2 squared, and you will get 1. That's what you see here. Then we use the formula that we are very familiar with. The expected value of n times variance of x, 304 times 1. The variance of n, we know, okay, is 15 over 16. The expected value of x is 2 squared. Use the calculator and you will get 9 over 2. Question number 4, let me read it. Speedy Delivery Company makes deliveries 6 days a week. Accidents involving speedy vehicles occur according to a Poisson process with a rate of 3 per day and are independent. In each accident, damage to the contents of Speedy's vehicle is distributed as follows. They give you the amount of the damage. Okay, let me write it here. 0, okay, 0, 2,000, 8,000, yeah? These are the values of x and the probabilities. 1/4, a half, and 1/4. Good. Using the normal approximation, calculate the probability that Speedy's weekly aggregate damages, so we're dealing with S, yeah, okay, weekly aggregate damages will not exceed 63,000 bucks. So a few things. I have written a solution here. Note we have got delivery 6 days a week, and accidents occur at a rate of 3 per day. So in a week, yeah, in a week we have 18 accidents. Yeah, I repeat, we have an average of 3 accidents per day. Therefore, it will be on the average of 18 accidents per week. Okay, so this is your new lambda. That's for a week. So total damages S in a week will be compound Poisson with lambda equals to 18. Good. The expected value of x, that's easy. Just take this times this, 2,000 times a half, 8,000 times a quarter. So that will be 3,000. Expected value of x squared, just square the 2,000 times a half, square the 8,000 times a quarter, add them up, you will get 18 million. So the expected value of S, we know from our class, it will be lambda times expected value of x again. Expected value of S will be lambda times the expected value of x. Sometimes we write it as lambda m1. So 18 times how much? 3,000, you will get 54,000. The variance, also we have covered this idea. The variance of S will be lambda times, good, expected value of x squared. So lambda is 18, expected value of x squared we have. So you will get 324 million. Now we asked to find the probability of S less than 63,000. So we are using the, let me read the question again. The weekly aggregate damages will not exceed 63,000. Yeah. So we are looking for S less than or equals to 63,000. So using the continuity correction, we can write it as S less than 63000, again 63000.5, and then converting your S to a Z, you will get probability of Z less than 0.5. From the tables you will get 0.6915. Okay, let's go to question number 5. This question number 5 is taken, the solution is taken from the source. Let's breeze through it. Okay, we have on a time shuttle service has one plane that travels from Appleton to Zebrasher and back in each day. Okay, good. Flights are delayed at a Poisson rate of 2 per month. 2 per month, yeah? 2 per month. Each passenger on a delayed flight is compensated 100 bucks. Okay, good. The numbers of passengers on each flight are independent and distributed with mean 30 and standard deviation 50. Okay. So, okay, now let's read on. Yeah, you may assume that all months are 30 days long and that years are 360 days long. Calculate the standard deviation of the annual compensation for the delayed flights. Okay. All you need to do is get all the information correctly, place them all in one line, and basically you are done. It's not a hard question. Okay. The number of passengers compensated in 1 year S, again, the number of passengers compensated in 1 year S as a compound distribution. Now, the compound distribution, here it will be a compound Poisson because the frequency is n, the number of delayed flights in 1 year. Remember, the number of flights that are delayed, flights are delayed at a Poisson rate of 2 per month. So for a year it will be 2 times 2 per month, so 12 months it will be 2 times 12, it will be 24. So n, the number of delayed flights in 1 year, Poisson with mean 24. Good. Let's call y the severity. The severity y is the number of passengers on a delayed flight. Okay, the number of passengers on a delayed flight. Now they gave me the expected value of y is 30 in the question, and they gave me the standard deviation of y is 50, so the variance of y is 50 squared. The expected value of n, because we are dealing with 1 year, is 24. Variance of n is the same, 24, because it's Poisson. So let's read on. Since the frequency is a Poisson distribution, the variance of s is expected value of n times the expected value of y squared. Good. And we know the expected value of y squared, it will be the variance of y plus the expected value of y whole thing squared. That's what you see here. 2500 plus 30 squared, 3400. That's the expected value of y squared. Expected value of n we know is 24. 24 times 3400. That's what you see here. The variance of s is so much. Okay, that's the variance of s. So we are looking for the variance of 100s. So the variance of 100s, why 100s? Because they tell me in the question that each guy is compensated $100. So this one here, it will be, the variance of 100s will be 100 squared times, what's the variance of s? 81600. Okay, that's the variance of 100s. Remember, we are looking for the standard deviation. Take the square root. Okay, take the square root and you'll get the answer that you need. Okay, let's look at question number 6. Okay, let's read question number 6. Let me find it. Yeah, let me find it. Okay, I got it. You're given the number of claims, individual losses. We're looking at question number 6, yeah? Number of claims, mean 8, standard deviation 3, individual losses, mean 10,000, standard deviation 3937. Use a normal approximation, determine the probability that the aggregate loss will exceed 150% of the expected loss. Okay, so let's move the screen up a little bit. This is an easy problem. Okay, number of claims, individual loss amounts, they are mutually independent. We will assume that. The expected value of s will be expected value of n times expected value of x. We are given the numbers 8 and 10,000. You will get 80,000. The variance of s, also easy. Variance of n times the expected value of x whole thing squared plus the expected value of n times the variance of x. Use the calculator and you will get this large number. So we're looking at probability. Sorry, let me say that again. We're looking for the probability that the aggregate loss will exceed 150% of the expected loss. Okay, good. So we're trying to find the probability that s is bigger than 1.5 expected value of s. So this part here you can do it yourself because we're using normal distribution. Take 1.5 expected value of S minus expected value of S, so you'll get 0.5 expected value of S divided by the standard deviation of S. Clean that up a little bit and you'll get this probability of Z bigger than 1.25, and then you can go ahead and do you need to read off your answer? No, just pick answer, the correct response, C. Question number 7, let's read it. Taxi cabs leave a hotel with a group of passengers at a Poisson rate of lambda equals 10 per hour. The number of people in each group taking a cab is independent and has the following probabilities. Okay, so maybe I should write it here. The number of people and probability. So 1, 2, and 3, 0.6, 0.3, and 0.1. That's in the table. Using a normal approximation, you're asked to calculate the probability that at least 1050 people leave the hotel in a cab during a 72-hour period. Okay, a few things. In this question number 7, I have reworked it using some numbers here. What you can do is you can go through the solution, pause the video, go through the solution line by line and work it out yourself. But I want to make a few remarks about question number 7. First thing is, we're looking at lambda equals to 10 per hour, and we're looking at a 72-hour period, yeah? 10 per hour. So we're looking at a 72-hour period. Therefore, my new lambda will be, I'm calling it lambda 1, will be 720, yeah? So 720 per 72-hour period. That's what you see here. I'm calling it lambda 1. Now I'm working in 72-hour periods. Okay, so in 72 hours, let's call W. Let me use the same letter so you can follow the solution. Eh? W, the number of people leaving by cab, has a mean of 720 times 1.5. Now where do I get that? The answer is 72 times 15. Don't worry about it. Yeah? I told you just now that you can follow all the lines and get the answers. But I'm looking at my interpretation. I'm taking my lambda 1 as 720 because I'm considering a 72-hour period. And then I'm taking my lambda and multiplying by my expected value of x. Remember, this one here is lambda times expected value of x. But now we're dealing with 72-hour periods. This thing becomes 720 times this value here. You can work it out yourself. They gave me all the information here. 1 times 0.6 plus 2 times 0.3 plus 3 times 0.1. You'll get 1.5. Okay, you'll get 1.5. I repeat, this times this, 1 times 0.6, 2 times 0.3. So 0.6 plus 0.6 is 1.2. 3 times 0.1 is 0.3. 1.2 plus 0.3, 1.5. So that's expected value of x. So take this 1.5 times your 720, you will get 1080. Remember the other one? Lambda expected value of x squared. So that also we can do, except now my lambda is 720. The expected value of x squared, take this one squared times 0.6, this one squared times 0.3, this one squared times 0.1, you will get 2.7. So take 720 times 2.7, you will get 1944. So now you have your expected value and your variance. So I'm working in 72-hour periods. So I'm calling W the number of people leaving by cab, has a certain mean 1080 and a certain variance 1944. You can work it out the way that they have done it. Now W is assumed to be approximately normal, so we're asked to find the probability that at least 1050. This is the question, at least 1050. So using the continuity correction, at least 1050 should be bigger than or equals to 1049.5. You know the mean, you know the variance, you can convert your W to a Z, and then you can look up your tables and you will get 0.75. Number 8, the normal approximation is applied to a compound Poisson distribution with Poisson parameter lambda. The severity random variable is uniform on the interval 0 theta. So x is uniform 0 theta. So let's write down the expected value of x is theta over 2, and the variance of x is how much? Theta squared over 12. Okay, let's write this properly. Okay, good. What else? You asked to find the minimum value of lambda for which probability s less than 0 is at most 0.01. Okay. Now, the expected value of x we know is theta over 2, and the variance of x we know is theta squared over 12. So we can get the expected value of x squared, which is variance of x plus the expected value of x whole thing squared. That's what you see here, theta squared over 12 plus theta squared over 4, which will be theta squared over 3. Okay, this will be expected value of x squared. Expected value of s we know is lambda times expected value of x, which is lambda times theta over 2. Variance of s, remember we have lambda m2, or you can write it as lambda expected value of x squared. So I have lambda theta squared over 3. Probability s less than 0, change it to a z. So I have 0 minus lambda theta over 2 over the square root of lambda theta squared over 3. That's what you see here. So there's a negative here, 0 minus lambda theta over 2 over the square root of lambda, okay, you can write it yourself, yeah, lambda theta squared over 3. So this thing here, they said must be at most 0.01, so less than or equals to 0.01. So which means this value here, when you clean it up, you will get this, and it should be less than or equals to minus 2.326. This you get from the table, yeah. This value here is 0.01. If you look up the value in the tables, you will get 2.326 with a negative in front. So this thing here must be less than or equals to minus 2.326. You clean this up a little bit, be careful there's a negative here. So you have square root of 3 lambda is bigger than or equals to this, 4.652. Therefore your lambda must be bigger than or equals to 7.213. Okay, giving you the response from the multiple choice. Correct response will be B. Number 9, let's breeze through that. The mean annual number of claims is 103 for a group of 10,000 insureds. So expected value of n equals 103. The individual losses have an observed mean and standard deviation of 6.382, expected value of x, and 1781 standard deviation. So variance of x 1781 squared. The standard deviation of the aggregate claims is 22,874. So the variance of S, 22,874 squared. Calculate the variance of the annual number of claims. So we'll use this formula. Okay, expected value of n times variance of x plus variance of n times expected value of x squared. Plug in all the numbers that we have. This one we have, this one we have, this one we have, this one we have, the expected value of x. We are looking for the variance, okay, the variance of the number, annual number of claims. We're looking for this. Use a calculator and you'll get 4.8246. Question number 10. An insurance policy provides full coverage for the aggregate losses of the widget factory. The number of claims for the widget factory follows a negative binomial distribution with mean 25 and coefficient of variation 1.2. So the frequency distribution as a mean R beta, which is 25, coefficient of variation 1.2, which is sigma over mu. Now the variance over n, excuse me, let me say it again. The variance of n we know is R beta 1 plus beta. and the square of the coefficient of variation will be sigma squared over mu squared, which will be r beta 1 plus beta over r beta whole thing squared, and that will be equals to 1.2 squared, which is 1.44. Now since they gave us r beta is 25, then we can calculate the variance of n as 900. Okay, the severity distribution is given by a log normal distribution with mean 10,000 and coefficient of variation 3. So the solution says in a similar way we can find the variance of the severity. We are given the expected value of x is 10,000, and we can use the calculator and work out the variance of x as 30,000 squared. Okay, to control losses, the insurer proposes that the widget factory pay 20% of the cost of each loss. Okay, calculate the reduction in the 95th percentile of the normal approximation of the insurer's loss. Let's go through the lines. The aggregate loss S has a compound distribution with mean, this one here we know, expected value of n times expected value of x. It will be 250,000, the expected value of S. The variance also we can get using the formula that we are pretty used to by now. Plug in all the numbers, you will get this number here. The 95th percentile of insurance losses before the 20% co-payment is C. So again, the 95th percentile of insurance losses before the 20% co-payment is C, where probability S less than or equal to C equals 0.95, and using the normal approximation we can work out C as equals to 801,750. Not hard to do. Now after the co-payment, the insurance loss is 80% of what it would have been. So S prime is 0.8S. The expected value of S prime is 0.8 times expected value of S, and the variance of S prime will be 0.8 squared. Remember, A squared variance of X. Good. 0.8 squared variance of S. You'll get these numbers. And using the normal approximation, the 95th percentile of S prime is this C prime here, which we can get, which is 641,400. Okay, and when you clean up the numbers, you will get a reduction of 20%. That's why the correct response is C.